NASA embraces small satellites. Presented by Science at NASA. The earliest satellites of the space age were small. Sputnik, for instance, weighed just 184.3 pounds. America's first satellite, Explorer 1, was even smaller, at only about 30 pounds. Over time, satellites grew to accommodate more sensors with greater capabilities, but thanks to miniaturization and new technology capabilities, small is back in vogue. NASA is one of many government agencies, universities, and commercial organizations embracing small satellite designs, from tiny CubeSats to microsatellites. A basic CubeSat has 4-inch sides and weighs just a few pounds. A CubeSat can be put into place a number of different ways. It can be a hitchhiker flying to space on board a rocket whose main purpose is to launch a full-size satellite. Or it can be put into orbit from the International Space Station. Astronauts recently used this technique when they deployed the Miniature X-ray Solar Spectrometer, or MinXS, a CubeSat that studies solar flares. In 2018, NASA plans to launch the CubeSat to study solar particles, or CUSP. It will hitch a ride out of Earth orbit during an uncrewed test flight of NASA's Space Launch System. CUSP could serve as a small space weather buoy. Eric Christian is CUSP's lead scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland.
Right now, with our current fleet of large satellites, it's like we're trying to understand weather for the entire Pacific Ocean with just a handful of weather stations. We need to collect data from more locations.
For certain areas of science, having a larger number of less expensive missions will provide a powerful opportunity to really understand a given environment.
If you had, say, 20 CubeSats in different orbits, you could really start to understand the space environment in 3 dimensions.
NASA scientists are taking this approach of using a constellation of sensors to probe the details of a large area with a number of recently launched and upcoming missions. The Cyclone Global Navigation Satellite System, or CYGNSS, launched in December 2016. CYGNSS uses 8 microsatellites to measure ocean surface winds in and near the eyes of tropical cyclones, typhoons, and hurricanes to learn about their rapid intensification. These microsatellites each weigh about 65 pounds, larger than a CubeSat, but still very small compared to traditional satellite designs. Additionally, the first 4 selections from the In-Space Validation of Earth Science Technologies, or INVEST program, recently began launching. The goal of the INVEST program is to validate new technologies in space prior to use in a science mission. Raven, the first of the INVEST CubeSats, was launched in November 2016 to demonstrate a new way to measure radiation reflected by Earth. The next 3 INVEST missions to launch, HARP, IceCube, and Murata, will demonstrate technologies that may pave the way for future satellites to measure clouds and aerosols suspended in Earth's atmosphere, probe the role of icy clouds in climate change, and collect atmospheric temperature, water vapor, and cloud ice data through remote sensing, respectively. NASA's Science Mission Directorate is looking to develop scientific CubeSats that cut across all NASA science through the SMD CubeSat Initiative program. Andrea Martin, Communications Specialist for NASA's Earth Science Technology Office, believes this is just the beginning.
CubeSats could be flown in formation, known as constellations, with quick revisit times to better capture the dynamic processes of Earth. Multiple CubeSats can also take complementary measurements, unachievable by a single larger mission.
She envisions big things ahead for these little satellites. For more news about CubeSats and other cutting-edge technologies, both big and small, stay tuned to science.nasa.gov.